Welcome to this lesson on subroutines and function procedures. After studying this lesson, you will be able to create and call an independent subprocedure, pass data to a procedure, explain the difference between passing data by value and passing data by reference, associate a procedure with more than one object and event, explain the differences between sub and function procedures, and create and invoke a function. Functions and subroutines will allow us to implement our coding in modules. Good modular programming involves principles of high cohesion and loose coupling. High cohesion means to focus on a single task or purpose. It is lean and mean and reduces bloated code. It focuses upon doing one thing well, but in the most robust and flexible way possible. Less code, which is to say more compact code, results in fewer bugs, easier maintenance, and is more readily reused. The principle involved here is to use the right tool for the right job, as opposed to the wrong tool for every job. For accessibility purposes, I'll narrate that this slide has a picture of a scalpel, a very specialized surgical tool intended to do a few things very well. It also has, in the opposing corner, a Swiss Army knife, which is intended to be a very generalized tool, but is not very comfortable to hold and probably doesn't do any of its tasks particularly well. Its benefit is that it has a tool for every occasion. In terms of survival, maybe a benefit, but in terms of surgery, I'll take the scalpel. Thank you very much. The second essential concept of good modular programming is loose coupling. Loose coupling means to focus on standalone, independent units of code. Code that is not tangled up with other code modules and has no interdependencies. A loosely coupled module is complete. It does the entire, one highly cohesive, task as intended. It is easy to copy and reuse in other code projects, and it won't fail due to missing pieces or unfulfilled dependencies. Tightly coupled equals tangled. Loose is better. For accessibility purposes, I'll narrate that in this picture and this slide, the lower left-hand picture shows a fishing tackle box with a number of lures that have all been tangled together. Very difficult to use and time-consuming to untangle. On the right-hand side, there's a picture of a well-organized, compartmentalized, or you might even say modularized tackle box, where all the fishing gear is separated individually so that it can very quickly be used, reused, or put back. Now let's explore how we can apply the principles of good modular programming using independent subroutines. Okay, so I have a little demo program up here, and the scenario is we're going to imagine that RK Maroon of Maroon Studios that makes cartoons has contacted us and wants a program developed, and it's going to be the first of a much more robust program that helps to automate the gags for cartoon characters. And the first gag we're going to implement is the old looking in the hose that's not working inexplicably while by character A, while character B then unkinks the hose or turns the valve and sprays the character A in the face. And I like this analogy because it will lend itself to something that we'll see that happens with global variables and why they are a poor idea, because changing a global variable that was created by another programmer is very often equivalent to turning on the hose that your other programmer is looking into. You're working at cross purposes. So that's kind of my way of remembering this or understanding this lesson. Okay, so we're going to have in our first cut at this project a set of radio buttons that turn our hose on and off. So the hose status is on or off is the control, and then at whatever point in the cartoon the character is to look in the hose, we push the button, and depending on what the hose status is, either if it's off, then the character is nice and dry, and if it's on, he gets sprayed right in the kisser, gets sprayed in the face. Okay, so let's take a look at how this is structured. And so if we look here, the first thing that the programmer has done in developing this is to set up a form level variable. And this is going to be scope for the whole form. So anywhere in the form this variable is going to be in scope. So it's like a global variable. It's shared by everything underneath this. Windows Forms projects don't exactly have the kind of variable scope that we would think is project-wide or multi-project-wide global, but this will do to model it. So anywhere in this form, host status is going to be available and usable within our code. Okay, we've set it up as a Boolean, true or false, and we've initialized the default to false. Okay, and then here we have the radio button on, and when that radio button is the status is changed, then it will immediately toggle whatever the value of the global variable host status is opposite what it was into the new state. So if it was false, it'll go true. If it's true, it'll go false. So every time we click on the radio button and change its status, we're going to toggle that. Okay, so we start out with nothing set, and then click on it. It's going to set the host status to on, and if we hit the button, we'll get sprayed in the face. Okay. All right, so then let's take a look at the push button, and when button look, we've named it, gets clicked, we're going to say, hey, if host status, so if the host status, we could say if host status equals true, but it's a Boolean, so it's either true or false. So if true, then you got sprayed in the face, and otherwise it's false, you're nice and dry. So if it's on, we get sprayed in the face. If it's off, we're nice and dry, and we're showing that with the message box. Okay, and that's basically it for this part of the code. So let's go ahead and see this much running. Okay, and I've left some room. I've actually concealed some things here that I've already developed. I'm hiding them with the panel because we're going to use those shortly. So right now, to focus your attention here, I'm just showing this part of the code. So the host status is on. We press the button. We got sprayed in the face. And if it's off, we're nice and dry. Okay, so that's working, and so far so good, and we haven't done any modularization of our code, and we haven't explored the concepts of cohesiveness or coherence. So let's take a look at why that's going to arise. Okay, so we've developed version 1.0 of our code, and RK Maroon is very happy, and Roger Rabbit's going to use it in the next starring role for the water in the face gag, and it's going to be wonderful. But RK Maroon calls us back and says, hey, we have to work with human beings, and we have to work with toons, and cartoon characters would really respond better if the interface was a toon rather than a text format. So let's go ahead and get rid of this panel that I put up here to conceal it. And voila, here is our cartoon-based interface. So we have a text-based interface, we have a cartoon-based interface depending on user preference. And so what I've done here is I've got two picture boxes. I'm moving them aside so you can see. One that's got a grayed out version of the image of somebody turning the hose bib valve, and the other one is not a grayed out version, and so that's supposed to denote when it's grayed out, it's turned off. When it's not grayed out, it's turned on. And then here is another push button, and we've coded up the click event there. So when you push on it, the character looks into the hose, and then we'll find out if he gets sprayed or not based on whether this is on or off. Okay. One other thing I've added that you'll be learning more about in future lessons, I've added a menu strip, and on the menu strip, I'm going to allow you to select the interface, and it will hide the elements of the text-based interface if you're using the Tune interface, or it will hide the elements of the Tune interface if you're using the text-based interface. Okay, so let's take a look at how we're going to develop this code. And I'm going to come back over here. And I've used another feature that I'm not going to discuss till the end of this lesson. It's kind of a more advanced topic and not part of this lesson. But I've created regions to help organize our code. So I'm going to turn off the interface text logic, which is what we were looking at before, so that we can focus entirely on the tune logic. And notice I can expand that out. Okay, that's the useful thing about regions. It doesn't do anything to alter the way the computer runs the code, just the way that human beings look at and can organize it. So it's a little easier to keep our focus on what we're interested in. So here is the interface tune logic stuff in this region here. Okay, so we have the picture box hose valve, and mostly to show that I can, not because it's really a better choice, rather than coding the click event, I've changed the status based on when the mouse leaves that picture box. So you mouse into it, nothing happens, but when you mouse out of it, it changes the picture status. And what that's going to do is, here's our global variable. It's going to change whatever it was to not that. So if it was on, it's off. If it was off, it was on. And we're going to flip which photo is visible. So again, if this is the picture box hose valve, that's the on one, it's going to turn it to not visible, and it's going to turn the picture box that has hose valve off, the grayed out version, is going to become visible. So it just toggles the two, flips which one's visible. So we've got one that to start with, the off is made invisible, and the on one is the one that is set to visible. So by making them visible or invisible, when it's invisible, it can't be clicked. It's also sort of like disabled, right? So its code would still work, but there's just no way to get to that. So that's what we're doing on our interface there. And then we have our hose valve off. So if we are leaving that, again, it flips the status of what's visible and not visible, and changes the hose status from off to on or on to off, whichever is the opposite. In this case, we're leaving the hose valve off, so it's going to go to on. But as long as we started in the right state, it's going to keep track of that for us, and we've flipped from off to on when we leave that. Okay, and so here is our first idea about how to code up the picture box that's acting like the push button to look in the hose, which is picture box look in hose. And so our first idea here is simply copy exactly the code from the text interface push button. So this is exactly the same code that we were using before. And it says, hey, if hose status is true, then you got sprayed in the face. If it's not, you're nice and dry. And let's see how this works. Okay, so we're starting with both of our interfaces being displayed. I'm going to leave them both up side by side for a moment so you can see if I enter into this box, as soon as I leave it, it turns off. I could easily have coded that for the click event rather than the mouse exit event, but I wanted to show you another event that you can code. So there's an example. And then we come over and click on this guy, and we're dry because remember when we left it, it's grayed out. We turned it off. Okay, so if we come back into it, we leave it again, it turns on, and we look in the hose, and we got sprayed in the face. Okay, so that all appears to be working just fine. Okay, here's the problem with this though. Remember that our idea was in modular coding to eliminate duplication of code, make sure that there's a lot of cohesion. Each module focuses on doing just one thing, and also there's a lot of coherence. And so there's not a lot of interdependence. And those are all true, but we really haven't achieved any modularity in code reuse. We've duplicated code. And here's the problem with that, is that down the line, if we need to change how the spray in the face stuff works, you're going to need to remember to change that code in two places. Having the same code in multiple places, because here it is under our picture box looking hose. And if we go back and check our push button, here it is, the same code there is duplicated. And so the problem with this is that anytime we change it one place, we're going to have to remember to change it in the other place. And that's really kind of a poor idea. Okay, so let's get rid of poor idea number one. Let's comment that all out. And let's see about idea number two. Now, you may have caught this as sort of an advanced trick or technique that I showed in one of our previous videos, but remember the push button event that we wired up to the event handler for when that push button gets clicked? That is the event that is tied to a subroutine. We've been using subroutines all along and haven't really realized it. So if we go back and look at the button click event, this is, oh look, it's a sub. This is a subroutine, okay? And we've just wired it up so that it automatically responds, gets called in response to the event of that button being clicked, okay? So that's what we've handled. We could actually add things out here so they handle multiple events. So one of the ways we could do this is we could say it handles this and it handles, and then we could go and say, well, the picture box look in hose, it handles that one as well, and that would be perfectly okay. We could wire that up, that would work. I'm going to do it a little bit differently to show you that we can call that subroutine. So the second idea is, what if we just called that subroutine directly, and we need to provide it the sender and the event arguments, but we had already received those as part of the look in hose, the picture box look in hose click event. So it got what the object is, and so we'll just pass them along. We're just reusing them, and so we're calling that. So now this second push, the GUI or the tune version of our push button look in hose, which is really a picture box, is going to call the same event code. So that's code reuse. That would be better. Does that work? Well, sure it does. Okay. So now if I look in the hose, got sprayed in the face, look in the hose, got sprayed in the face. Okay. So that's all working very nicely, because when I click on this, it's actually running the code associated with the push button for look in hose. And that's fine, except it does kind of bother me that our tune interface is now fully dependent on the text interface being available to it. And at some point in the future, we may want to get rid of one of these interfaces. And if I get rid of this, I will break it. So that doesn't follow the idea of coherence. It's not avoiding being entangled with external dependencies. These two are now intertwined. So let's take a look at another way of doing this. And so let's go ahead and comment this back out. And let's take a look at idea number three. And idea number three is, hey, let's code our own independent subroutine. An independent subroutine is one that is not wired up to be hooked by an event. Okay, it has to be called explicitly. And so if we take a look at the independent subroutines I've got out here in code, Okay, so here's the one. I've called it look and hose global because it's still using that global variable, which troubles me, right? That's actually a global variable is going to be an external dependency, so we're not free of that yet. But let's just take a look. What if we change this to call look and hose global? So we'll uncomment that. And then let's go back up to our original push button in the text interface. And, you know, instead of having its own copy of that logic, let's comment that out. Let's have it also call look in hose. And we'll use the global version. Look in hose global. Okay, so now both of these event-driven subroutines are calling the same body of code. They're both calling look and hose global. And what's in look and hose global? Here it is. Well, it's just, it's really the code that was there to begin with, that we were using in each button. But now we only have one location in code. If we ever need to modify this, we change it one place, and everybody inherits the creamy, golden, delicious goodness of that code being changed correctly for everybody. So we can't orphan one piece of code and have a bug because one version works one way, another copy of the code that's in our program works a different way. So let's see if that's working. Okay, so look in hose, sprayed in the face, look in hose, sprayed in the face. Lovely. Okay, and I'll give you a little glimpse at what the interface stuff does. If I select the tune version, it makes the entire text stuff invisible and still works the same way. And if I change the interface to use the text version, it hides the tune and still works the same way. Okay, so far, so good. Let's take a look at the one remaining problem that we really still need to solve here, and that is look and hose global is still dependent upon what? Hose status. And hose status is that form level or global level variable that was declared initially. And that means if I were to go and want to reuse this subroutine in another program, I copy and paste it or whatever, the look and hose subroutine is not truly independent. It has an external dependency. So even though it's modular, and even though it is highly cohesive, it really does just one thing. It reports on whether or not you got sprayed in the face. It does not maintain independence. It's still highly coupled. So it's not as coherent it could be. It's coupled to that global variable, which means, at the form level, in whatever code we were to try and reuse this this module in, we'd have to have this global variable. And you're probably going, well, how can you get around that? How do we not have that? And we'll see that in our next lesson. Now that we have some programming experience and have started to explore modular programming concepts and principles, we can really begin to see why using global variables is a poor practice. Declared in the main code, global variables undermine the principle of loose coupling. They become an external dependency. When used or abused in this way, global variables are often referenced in many different modules, often for different purposes. This undercuts the principle of high cohesion. Changing the value of global variable in one module can easily break a separate module that also references that variable. So the question here will be, if using a global variable is a poor practice, what's the alternative? In this slide, in the lower left-hand corner, there is a picture of a cartoon character looking into a hose that is turned off and not functioning. In the lower right-hand corner, there's a picture of a hand turning the valve on a hose, the result being that the character in the first picture is likely to get sprayed in the face. This is an analogy of programmer A working on the same program but different parts as programmer B. Programmer A is like the cartoon character who doesn't understand why suddenly his code is not working or turned off. Programmer B has unknowingly turned the valve by changing a global variable that Programmer A's work was dependent upon. All right, in this lesson, we're going to take a look at what we do to try and avoid ever having to use global variables. We can use local scope variables to a much greater extent. Before we focus on how to do that, we probably ought to talk about why to do that. Here's the problem with global variables, and that is they're out there, and since they are a variable, any programmer that's working on the code, and code can get quite large and have many programmers working on it over time or even at the same time. And so what can happen is one programmer may make assumptions about the status of the global variable. Another programmer may be using that global variable, including their code may update that. And if they update that at a time or in a way that is not accounted for or anticipated by the other programmer's logic, you can have a lot of awful things happening or funny things happening. And it reminds me a lot of one person looking in a hose that I don't understand. I turned it on, it's not working. Why is it dry? Is there something in the hose? And I put my face up to look in and see. And the other programmer then essentially turns the hose on and sprays me in the face. Okay, so let's see how that can happen here with this code. You may not have caught the bug because it's subtle and I was careful to try and work around it. So I've got both my interfaces on right now so I can show what happens here. So again, let's show that they work independently correctly. Look in the hose, got sprayed in the face. Turn this off, look in the hose, nice and dry. Turn it back on, look in the hose, sprayed in the face. Okay. Now let's come, and as we exit this, it will turn it off. And if it's off, I should be nice and dry. Yeah, except notice what the status says here. This status did not get updated because that global variable got updated in the code from programmer B, who didn't anticipate that would happen at that time. So one is now showing on and one is showing off. It really wouldn't be apparent if we were only running one, other than in having changed that without this code being aware, it should be on. I should get sprayed in the face, but I'm dry. And if it's off, I should be dry, and I got sprayed in the face. Well, what's happened is one programmer's code has allowed the other programmer has allowed the variable to be changed without the other programmer's code being aware of it. And so we have this, this situation where the bug manifests, and every programmer that's independently unit testing only their code may say, "Hey, I've done everything right. I don't understand what's wrong." And one program has undone the other, and really it's not the bug of programmer A, it's not the bug of programmer B, it's a consequence of this poor practice. So if we look at our code, can we figure out what's happening? Well, yeah, notice that all of our code that changes things is just flipping it. It's not checking what the status is. Would it be possible without, while continuing to use the global variables to sort out my code so that anytime that the picture box status got changed, that we also change the status on the radio button, and the radio button, if it gets changed, it changes the status on the picture box so that we keep them in sync? Well, we could do that, but think about the complexity. How many places you have to change the code to coordinate that? Isn't that kind of a mess? And that's, if you think about it, that's also creating a whole bunch of external dependencies, which again violates our good modular programming. So how can we arrange it so that at least if we're running independently, we don't have, so let's run this again. We don't want to have this situation where this guy having been updated without letting this guy know can cause this error to occur so that they're flipped. How can we try and do that? Well, one of the things that we can do with subroutines is we can pass arguments to them, okay? And we pass an argument. The argument we pass can be passed from a local variable rather than a global variable, okay? So we could actually get rid of our global variable altogether, okay? At this point, I've just broken the code. Notice that it's saying, well, I don't know about these. There's no reference there. So I've done away with that global variable. So we're going to have to do some cleanup in all these portions of the code. And what we're going to do is we're going to create, we had this look in hose global subroutine that was using the global variable. Let's create a version of it that, now notice there's a slight difference in the way that this variable has named. So it's going to be not hose underscore status, it's going to be hose status. And whatever variable gets thrown to it is going to be accepted, the value will be accepted, and it's going to be renamed here as hose status. So if I pass hose underscore status to it or something else, it's going to be renamed here. And this is a local variable. It will respond to whatever the status is that was sent to it. So if we send it the right status, we get the right result, regardless of what interface sent it. So we can use parameter passing, and we do not have to pass it a global variable. We can pass it a variable that is local to the portion of the code that is calling this function. Okay, so what we want to do is anywhere we were calling look in hose, we want to make that call, or what it was calling look in hose global. So let's go ahead, and this is our fourth idea, is to make it independent passing parameters. So let's comment that out, hide that region, and let's call it this way. Okay, and so we're going to call passing local variable. Now, so we're going to have to change this from hose status, where in our tune interface can we get the hose status. Okay, so I'm going to change this so that we know that what we're calling is a variable that is local just to this subroutine. Let's call it my hose status, and let's say dim my hose status as Boolean, and let's say my hose status equals, and what drives the tune interface status? It's really what picture box is turned on. So it's going to be the same as PB hose valve dot visible, right? So if PB hose valve is visible, then which if that's true, then my hose status is true, which is to say the hose is on. Okay, and we call that. Okay, and we need to do the same thing for the text interface for the push button. Okay, so let's come up to our push button for looking in the hose, and instead of calling the global version, let's call the parameterized version, and let's call this one your, or maybe we'll call it, instead of my hose status, this is text hose status. And we haven't created that variable, so let's create it. Dim text hose status as Boolean. And what drives the status for the text control, the text side interface? Okay, so that's going to be the checkbox. Okay, so we're going to say text hose status equals, and it's going to be the let's see, the radio button on dot checked. Okay, so if it's on, if the radio button on is on, then the text host status checked is on. Now we're still dealing with these two interfaces as if they're always going to be separate. We haven't done anything to synchronize them. We could add more code to do that. But let's just see if we've got this right so far. And we've got some references to the old global variable. And so sub radio button on, when this check changed, we're changing the hose status. Well, we don't have to do that now because we're checking it here. So we can just comment this old code out or delete it. And what else is problematic? So on the mouse leaving, we're changing the hose status. Again, we're taking care of that elsewhere. And so same thing with the when the hose valve goes off, we can just comment all that out. And then, okay, so I'm going to comment out the old global subroutine altogether. We no longer are calling it and don't need it. So here we're calling the parameterized version. So this independent subroutine gets handed a local copy either of my hose status or text hose status, and it always responds correctly because those two variables are now completely separate, but they're compartmentalized. They're not two separate global variables. They're two private variables, and the only reason a copy is available is because this gets called. And so parameter passing arguments is the way we want to get around being able to signal or share information between different code modules without having an external dependency on a global or more public variable. Let's see if this is working now. Okay, so turn this off, look in hose, I'm dry, turn it on, I'm wet. Okay, that seems to be working. Turn this off, look in hose, and I'm dry because it's off, even though these two don't agree. We haven't done anything to synchronize the two interfaces, but we have solved the problem so that if we turn the, if we were to go in and, so now they don't agree, but if we switch to our text interface and look in the hose, it's correct. The bug has been fixed. And off is dry, and change our interface back to the tune interface, and we leave it and it's dry, and if it's on, I'm wet. And so we have solved that problem, and we have nice modular code that is also consistent with the ideas of tight coupling, or excuse me, loose coupling. So there's not a lot of independency, also called being highly coherent code, and it is also highly cohesive code. It's also highly coherent. It does one thing. We don't have spaghetti code that's trying to do 5 different things. We've broken the logic, and that keeps the code small and manageable, easy to debug, and We could also easily reuse these modules now because the subroutine that we made as an independent subroutine, because it is essentially all self-contained. It's not dependent now on an external variable. We put that into a library file and then include that file in another project, or just copy and paste that subroutine in, and it will work really without any problems. So cool. So we've seen us iterate through the different ideas here in solving the problem of enhancing this code. So first idea was we'll just duplicate the code, but then we have duplicate code to deal with. The second idea is, well, I'll call the original event handler, and that's not a bad idea on a limited basis, but again, it means that one part of that code is dependent on the other piece of the code, and that means they're tightly coupled. I can't use the second one unless the first one is present. And then the third idea is, well, let's put everything in an independent subroutine. And that was a great idea, except that we were still using global variables, and we could see that if you're not careful with global variables, you'll catch it in the face, I guess is the lesson here. And our fourth and final idea is we'll use an independent subroutine that we have parameterized so that we can give it, pass it a local variable value from our calling part of the code, and it will work independent of any other local or private variables that may be passed to this function. And so we have true independence. So we have loose coupling and high coherence and really good modular code at this point. All right, let's leave that there. In a previous lesson, we saw that we could create an independent subroutine and pass parameters to it in the form of a global or preferably a local variable. There's actually two ways that we can pass that parameter, and let's explore now what those two ways are and what the distinction between them happen to be. All right, so I've recreated a running theme from one of my favorite spy movies, James Bond thriller. And so we have the situation where we have to send James Bond into absolutely not survivable certain death. And I've coded that in a button here. And of course, we need James Bond to survive to continue making money off the franchise so we can continue to make movies. We can't kill him off permanently. And so we have the choice here, depending on the situation, to use a Bond clone or to use the original and to observe what the effects are. So the idea being that if we kill the Bond clone, we still have the original. If we kill the original, then I guess we move on and start making either animated features or perhaps we move on to Star Wars movies, but we won't have any more James Bond. So that would be unfortunate. Let's see exactly what we've done here in the code. All right. So in the push button routine, the click button on the button that I'm calling death. Okay, so button death gets clicked, and depending on whether you have checked the clone radio button or the original Bond radio button, we will call an identical function. It's named slightly differently. One is called kill Bond clone, and the other one is called kill Bond original. And let's see how those two nearly identical functions, or excuse me, subroutines are coded. So in both cases, they are going to change the string that is passed in to bond status dead. Okay, so both of them result in a dead bond. Okay, the difference is one of these parameters, bond, is being passed in by reference. The other one is passed in by value. And so here's the lesson we're trying to learn here is if you pass it by reference, that is actually not giving me the value that I'm to modify. It gives me the address in memory where the variable where that value lives is, and I go to that variable's home address and I monkey with the actual value of that variable. So by reference takes me to James Bond's home address, and I'm monkeying with the original James Bond. We kill him dead. Bond is dead. End of franchise. The difference is if I say pass it by value, what we're actually passing when we say bond is the value of bond. So it was a string. So it comes in and it may have said bond status was shaken but not stirred, or shaken but stirred, whatever. But we're changing it, okay? When we change the copy of it, we're changing a clone. The original bond hasn't changed at all. If we're past the address of the original bond, as it were, if we change the contents of that variable, it is in fact changed for once and for good. And so let's see that actually in action. So verify for your own sanity that both of these functions are coded exactly the same way, with the exception one is being passed by reference and one is being passed by value. Okay, so now nothing up my sleeve. Let's run the code. And if we say send 007 to certain death, and he's shaken but not stirred, he's not dead. Okay, and bang, 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 doesn't matter how many times I kill Bond, he's still just fine. Unless, of course, I use the original, at which point Bond is dead. Okay, so what's the distinction? Let's see this in the debugger so we can really catch what's happening here. So I'm going to come in and put a breakpoint in just when these, let's put it down here at the end. And we're going to put in our watch window the bond variable, okay? But what we probably also ought to put in our watch window, our variable watch window, is the name of the variable that we're calling it in. So it's the this bond. Okay. Now there would be absolutely no reason that I couldn't just call them all by the same variable. So this is bond, this is bond. I could very easily have declared this as bond because this is a local scope variable. So it's like having multiple people in the same classroom named Pat. Okay, it's totally okay to have multiple people named Pat. We can keep track of them because the teacher knows that there's a difference between Pat, who has one student ID number, and a Pat who has a different student ID number. Local variables don't interfere with each other. So we could call them all bond, okay? But I think it's less confusing to see what's happening if we give them slightly different names. So I've named them differently. Actually, in practice, we probably would call them all the same name just because the fewer variable names we have to keep track of, the better. But this helps to emphasize that this is the local variable that I am passing. And if I'm passing it by reference, the actual address in memory of this bond is going to be where we go to make our changes, which will result in permanent changes. If we pass a copy, only the value is being passed to this function. And so essentially a copy, a clone, is being passed. You can do whatever you want to it, and the original this bond will not be changed. Okay, so let's see that actually happen. So let's use a clone. I send bond to certain death. Program breaks. Now it's already run right here. It's showing us that it's run that. And if we look at bond, this bond variable the string has been changed to bond status dead. Okay. It does not matter how I change that though. The original this bond is now right now he's out of scope because remember he's a local variable. But watch as soon as we step through and return to the calling function, this bond now is back in scope, and he's shaken, not stirred, not dead at all. So only the clone was killed, not the original. And F5 to continue the run. Now let's change it to use the original bond, send with certain death, and this time the kill bond original version of the function, excuse me, subroutine was called. The bond variable, so this is the copy that was passed in. Okay, only it's not a copy, it's by reference. So we're referencing that actual location of the original, and it says the status is dead. And then let's hit F10 and step out of it. So we step back up to the calling function, and oh look, the original bond is dead as well. So it's permanently changed. Okay. So what's the benefit of having it, temporary? We didn't really do anything with this bond variable in the function, even when we were calling it by value. So you're like, well, it's never going to change. What are you going to do on that? Well, we could have some local logic here that we could code up that it would, do some whatever we're going to have it do. So we can make decisions or other calculations and have the program do other actions at that point. So it really does have value. It's not a pointless exercise. All right, so let's pause for one other thought before we conclude this lesson, and that is, so we've used this subroutine, and in one case, we actually end up with some tangible results back outside of the subroutine. And it's only by passing it by reference. Otherwise, subroutines seem to be kind of one way. We throw them a task to do, we provide them with parameters if we need to, and they do it, and then they're done. Is there another way, a better way to get results back when we need them than having to pass by reference? And the answer is yes. And that's where functions come in. And we'll see about functions in the next lesson. So far, we've seen that subroutines are really handy if we want to avoid duplicating code, and creating an independent subroutine is a great place to put code that we want to run time and time again, and possibly to call in common from many different parts of our program. However, we haven't seen a real great way to call a subroutine and get something back. The only option we've seen so far is if we were to pass it a value by reference, and the problem there, of course, is the original value then gets overwritten by the changed value updated within the subroutine. So subroutines really are kind of best when we want to do a batch of things and then move on, when we're not looking for something to come back from that. We want the action taken, but we're not looking at formulating a new value. So what do we do when we want to have modular code that gives us a new result and maybe does, maybe doesn't make any modification to the original variables or arguments that we passed to it? Okay, this is where functions come in. So let's take our James Bond example and extend it to work with some functions. So here I'm going to do something pretty trivial. I've got a text box, and you're going to enter a decimal value or integer value. It's declared as a decimal, so it'll handle either. And you're going to run this double it push button. And when you click on double it, it is going to call one of two functions. And again, we're going to do it based on whether we want a clone or the original. And as you've guessed, that's going to determine whether the arguments are passed by reference or by value. And the results of that, both the original x and the returned value, the doubled x, are going to be displayed overwriting whatever the original value of x was and the new double x. So let's take a look at that code and how it works. Okay, so here are our two functions, and again, you're going to find that internally they are absolutely identical. And what it's going to do is it's got a local variable called myvar, my variable, and it's going to be set to 2 times whatever its original value is. And then there's a new keyword here, return myvar. And so what it is going to do is it's going to provide a result back. And that result is going to be the calculated result myvar. We've done the same thing in double it ByRef as in double it ByVal. Let's take a look. The difference, as you might have guessed, is in one case we're passing the incoming variable by value, because remember that's a copy of it, and the other one by reference, which is the home address and memory of the original location and contents of the variable being passed in. So in this case, if we make any changes to myvar, which we do, it's going to change the original value passed in, but in either case, we're returning a result that can be used. Okay, because we are returning a result, functions are declared as type, because this function that returns data that has to be a specific data type. So we're returning a decimal type, so this function is declared as decimal. Okay, the argument being passed in also has to be declared by the type that it's expected, and here we're expecting a decimal in, and we're returning another decimal out. Okay, so those are the two, and again, the difference between them is in one case we're passing by reference, the other case we're passing by value. In both cases, here's our routine on the click event for that double it button. And so I've got a variable I'm declaring as X. I've got another variable I'm calling result. Both of those are decimals. And I'm going to go ahead and try to parse out the text box. If you enter a valid number, I can convert it to a decimal. And then I look and see whether or not that radio button clone is checked. And so if you said you wanted to clone, I'm going to use the ByVal. And if you didn't, so it's going to pass by reference. So this one is going to send me a clone of James Bond, if you want to think of it that way. So whatever I do to it will not affect the original James Bond or the original X. And this one is passing the original James Bond, his home address, and so anything you do to monkey with it is going to leave a mark on the original James Bond, and so this will modify the original value. And then once all that is done, then I'm taking the X, whatever its state is, changed or unchanged, and writing it back out to the original X text box. And I'm doing the same thing with result, and I'm writing that out to text double X text box. So let's see this in action. Okay, so let's assume, let's see, for the sake of nostalgia, 007, so we'll put in 7, and let's use a clone, and we say double it. Okay, so we've doubled 7 as a clone, which means the original X, no change is really going to occur to him, but the result that we got back was 14. And if we put in 25 and doubled it, 50. Okay, so that's working fine. But what if we were to use the original? There's my 7, and now I say double it. I did double and get 14, but because we made that change by reference, so it affected the original value being put in, it has doubled that as well, which actually may be desirable, depends on what your intent is. Notice that the handy thing here is when I run this by using the original, I'm ready to go for the next run, and I can keep doubling the number. However, if I say use clone, double it, the original wasn't changed. So if I keep hitting this, it's just going to keep recalculating. Double of 7 is 14, and on and on and on and on. So if I wanted to change it, I have to do so by hand. So which is the right one to use depends on the situation and what you are trying to achieve, and whether or not you need to preserve the original value of X. If you do, then you're going to use ByVal. If you don't, then you can pass the original in ByRef. Okay, so let's see what other observations we can make here. There's some other interesting things to be seen. Um, Let me put a breakpoint right before the end of the click button. And I want you to notice something. You've been using functions really without thinking about it or really knowing it throughout this entire course, and there are a number of built-in functions. So for example, the try-parse method is a function, and it returns a value to you, and then you, based on the value returned, you do something with that. Okay, and that's built-in piece of the language. Notice how we call the functions here. So we've set result is equal to double it by that we call the function. Okay, do you notice that this looks exactly like the syntax and notation of built-in functions? That's right. So when you think about it, if you want new functionality in the language, you are empowered to create it by writing the function logic, and you can create a whole library of functions that you would keep and reuse in your code or share with others or even sell commercially to be used as a commercial library for doing specific programming tasks. And it extends the language. Functions extend the language, and they are co-equal with the built-in functions of the language. In fact, at heart, there are no built-in functions of the language. All of these built-in functions are part of the libraries called the .NET framework. If you're programming with the .NET framework libraries, which we are, that Microsoft has provided. So you are equally empowered as Microsoft's programmers to extend and continue to improve the language and its capabilities. And we generally do that with add-on libraries rather than building them into the original .NET framework. We try and keep those as light and as small as possible so that we don't carry, when we compile our code, we don't carry a lot of bloat. We don't carry code in there that's never being used. So we don't want to include functions there that aren't going to be called by the program in question. But by selectively grouping together any functions we create into the library files that we choose to include, and we'll see a little bit more about including different libraries as we move forward in our programming. But by keeping out anything we don't need, we keep our programs fast and light, and we can also find what we need by putting the similar or related functions together into a library file and naming that library in a way that helps to make sure you understand. Like the math library, you would expect has advanced math functions. So we have a baseline of math functions that are built in, as it were, to the .NET framework, and then we might have more sophisticated or extended statistical functions, things that people don't use all the time, in a math library, and that's exactly the case. But let's prove once and for all that the function that we just wrote is co-equal with functions that Microsoft has provided for us. So we've got this breakpoint here. Let's go ahead and run our code. And now it's stopped, and I'm going to come over to the immediate window, and if I tell it in the console, do a debug print of this function, double it, ByRef. Oh, let's do it by ByVal so we don't change the original. On 32. So we're just calling this function as if it were a built-in function in the immediate window to see it exercised. And the result is 64. Pretty cool. So we call a function, it returns a value. All right. So for the sake of completeness, I guess there's one other thing we could note. Let's end the run here. And that is, it is not absolutely necessary to return a value from a function. So we could have, defined this function not to return anything, which makes it an awful lot like a subroutine when you think about it. So I'm not sure that's particularly useful, but the point is that you can certainly do that. So when to use functions, when to use subroutines? Typically, we use functions when we're creating a calculation that is to, or a procedure, a process that is to return a value. And when we just want a bunch of things done and we're not returning a value, we just want the task completed, we might call a subroutine. And in either case, the parameters that we pass, the arguments that we use, can be passed either by reference or by value. And again, that's going to vary depending on whether or not you wanted to expose the original variable being passed in to make it subject to change, or if you wanted to make sure it is not subject to change, in which case you would send a copy of it, you would send ByVal. That's your clone. All right. All right, this mini lesson is really sort of a bonus lesson. I call it an expert or extra for experts lesson. You can skip over it without any harm. We're going to be touching on some of these concepts more deeply and applying them in lessons to come. But since I utilized in my examples so far some features that you haven't covered, for those of you that are interested, I thought I would show you what I was doing. So first, let's take a look at the regions command and why that's useful. So you saw when I was breaking out the code, I hid some of this from you by making collapsible regions so that when we were focusing on the interface text logic or the interface tune logic or the independent subroutines, that we had these collapsible zones, these collapsible regions that would hide or expand the text. And you can see when you have a long and complex program, it really is kind of handy to have this kind of expandability. Now, some of that's built in. You may have noticed already that you have the spinnies, the plus and minuses to pull out or expand or collapse the tree view of the text of your different subroutines and pieces of code here. Well, you can actually arbitrarily create your own, and the way we've done that. So, for example, here I've got, although I'm not using it anymore, I've got this global declaration. Well, often I'll have a whole bunch of initial variable declarations and that kind of stuff. And housekeeping. So if I wanted to sort of set that apart so it wasn't part of the clutter that the programmer has to work with while they are editing the code, we could create a region, and I'll give it a name, global variable declarations. And I'll come down here and the pound sign or pragma of end region. Okay, and when we do that, it doesn't make any difference to the logic. It doesn't change anything that the computer does in compiling or executing our code. What it does, though, is it makes this region of code collapsible so I can get it out of the way and hide it from view. And so merely a convenience, but that was what was going on with that, so that you know. If that's useful to you, by all means use it. It's not required, I think, in any of our exercises this term. Okay, certainly professionally you use that a lot because you can see how this, in a really long and complex program, this could really help to organize things. And you also, it helps you to organize your code better because you start saying, oh, this really belongs up in the interface tune logic. I'll put that up with the interface tune or interface text. And you organize your code better and have related things grouped together, which makes it much easier to maintain and understand and navigate if you're looking for something in a very long and complex piece of code. Makes it much easier to find it and think about how the code works and is organized. Okay, so that said, let's go ahead and expand out our menu logic, which I hid down here because we really haven't handled the menu strip control. So I dragged a menu strip control in over here, and when I did, you may have noticed that this is one of those off form controls. It doesn't show up here. You have your properties for it. Here you do get this one little piece, and then we can add additional horizontal choices and vertical choices to the interface. This is how we do a menu bar, essentially. Okay, and then in that, if I come up here, and so on this project, and if I were to select the menu strip item, and I didn't even bother to rename it, you can see all the different methods that can be used on it and can be coded. But I was interested in one of the submenus that I created for it. So we have the tune tool strip menu item, which I have coded, and the text tool strip menu item, which I have also coded. Okay, and what I'm doing there is I have coded it to go through a list using a loop, go through all of the controls that exist in the form, which they are a collection of controls. So we can use another construct which is for each, very similar to the for next. Each automatically knows how many controls there are in the controls collection. And I've said, hey, go through each control, and if the control has a tag property of interface tune, IF tune, then make it invisible, and otherwise go through, and if it says interface text, make it visible. So why am I checking for both? There's actually a third possible category. What if it's an interface element that exists in both the interfaces? So it would say, it might be null, or I might say interface hybrid or interface both. So I could leave that. So all the things that are exclusively tune, make them invisible. All the things that are exclusively text, make them visible. And similar kind of thing for walking through when you flip it the other way and you choose the tune interface, with one other exception. Remember that we start with the hose in the uh, turned on condition, so it specifically hides the picture of you don't want both the picture boxes visible at the same time. So the hose valve off, the grayed out version is set to false so that it's not visible, and then those will be toggled when you're using the tune interface. Let's see that, so it's a little bit easier to understand that way. Okay, so right now the hose valve on image is visible, and when I leave, it toggles it, and the hose valve off image becomes visible, and the hose valve on becomes invisible. So that's what we're doing there. Okay, and so one last comment we ought to also then talk about in walking that collection of controls is the tag property. And so if we come back over here and let's pick one of our controls. So here is the push button is only going to be an interface control. If we go look, I have set the tag property, which is kind of a user-defined value. I said this is going to be part of my text interface. I've done the same thing here. That's text interface. If I look at the picture box, that is the tag value is going to say, well, this one is part of the tune interface. And so that's how the magic is happening when we run the tool strip. And I say, well, just show me tune, or just show me text. No, show me tune again. And so the other thing that I could do, I haven't, for the sake of this demo, I could add another choice here. and instead of tune or text, we could call it, combine or hybrid or joint interface. And then we would add the logic that would turn everything back on, except of course for the off um, uh, picture box, which we want hidden initially. And we remember we just stacked those two one on top of the other. So as one goes invisible and the other one becomes visible, it looks like it's actually changed. Really, we're just a little sleight of hand, hiding one and showing the other. All right, so that's it for your bonus lesson. This concludes the lesson.